You know what space weather is. It occurs when our sun spews charged particles in the general direction of Earth. They interact with our planet's protective magnetosphere to cause aurora, those beautiful twisting, mostly green light shows, visible during the dark Arctic nights of late fall, winter and early spring. Want to see aurora? So head to the far north, to Alaska, or to London, Portugal and Madrid. Although aurora are reliably seen only around the Arctic Circle and Antarctic Circle, sever solar storms push the auroral oval further south. The stronger the solar storm, the further south the aurora are sighted. Historical reports of unusual auroras over places that normally never see them can therefore be used as a proxy for the study of solar activity before accurate scientific records began. And on March 6, 7 and 8, 1582, what's now known as the Great Magnetic Storm brought aurora as far south 29 degrees north latitude. The subject of a new paper that delves into newly discovered descriptions about this great aurora, they are a clue to a solar storm that must have been horrifically strong. If that happened now, it could leave vast populations unable to communicate and without electrical energy. The northern lights and southern lights occur most frequently between 64 and 70 north and south latitudes. In the northern hemisphere, that typically means between September and March in Arctic Circle, Alaska, northern Canada, Iceland, and Lapland in Norway, Sweden, Finland and Russia. In the southern hemisphere, that means between March and September in the Antarctica Circle, south of New Zealand over the oceans and in Antarctica, so they're more rarely observed. Knowing how often severe space weather events occur is important for a modern technological society like ours, because one could knock out electrical grids, communication systems and satellites. However, despite the number of sunspots on the sun, an indication of solar activity, being counted since the invention of the telescope in 1610, we don't have much data. And certainly not enough to tease out generational trends in solar activity to accurately predict when the next super-strong solar storm is likely to hit. A strong solar storm on March 13 and 14, 1989 caused a blackout in Québec, Canada, though the most important solar event in recent history was the so-called Carrington event, in 1859, which disrupted the early telegraph systems of North America and Western Europe. It caused aurora to be seen as southerly as 20 degrees north. It's the most powerful geomagnetic storm known to date and would be catastrophic to our modern society. So what happened in 1582? Probably caused by a series of coronal mass ejections, CMEs, on the Sun. For 2 nights it caused an auroral oval at mid-northern latitudes, which dipped further south on the 3rd night. It all occurred just before a full moon, too, which would have lessened the impact of the aurora. This one was big.